Hello everyone, welcome to another episode of your weekly dose of Terraform. My name is the same, Anton Babenko. Let me check. Yeah, okay. I hope you can hear me well. If not, then please let me know in chat. So, we have another episode. I don't remember which number of it, but anyway, it's great to continue these things, and thanks everyone who reach out to me from time to time and say when I do something good or bad. So highly appreciate feedback. So let's get started. So first of all, let me say thanks to M0 for supporting this live stream. They have published an article recently where they compare these two platforms and how they are different from Terraform Cloud, which you probably have heard of before, right? Well, you don't see me here on this view. Okay. Anyway, let's switch to another. Right. Okay. Hopefully, I will fix it later. So thanks to N0, and let's move on. So I also want to say thanks a lot to everyone who support me on GitHub sponsors as well as on Patreon and Open Collective. So thanks to these 17 sponsors plus a few more people who support on Patreon as well. So if you like what I'm doing and if you want to to continue these things, what I'm doing, and specifically in open source, please consider join. Hello, Tanya. And hello everyone. Well, there are so many people watching this time. I don't know why. Well, I know why, but we'll go to the subject a bit later, EKS. So I have another news for everyone. Well, normally I covered Terraform news during this live stream, but then I decided that it's not actually the best place because you guys probably don't want to see these live streams and then there are news somewhere in between. So I decided to talk to Ryan, who was creator of Weekly.tf, and he agreed that I'm now publishing and maintaining Weekly.tf website where I will publish a weekly newsletter about Terraform and pretty much everything what is related for Terraform developers and users. I'm going to publish first a newsletter in 3 hours. I think it will be awesome, but that's definitely how I think about what I do. But if you want to get these weekly messages, please write your email here, and remember to unblock your ad blocker, because when I have ad block enabled, then it just hides this form, and it took me some time to figure out why I cannot subscribe to this emails myself. Well, that's because ad blocker disabled this one. So stay tuned, and in 3 hours there will be an automatic email send where I publish some articles, some news. So stay tuned for more of this kind of content. The format of emails has also changed, so I'm not gonna to cover some things which were previously covered by Ryan before, because I think it's a little bit irrelevant. So stay tuned. And the last announcement which I want to make is that you probably know what is HashiCorp platform or cloud platform Vault. So this is an offering by HashiCorp, which they have released earlier, I think this year. And Robert Strand, who is also Oslo HashiCorp user participant, decided to share his experience, how they are using this inside of their company, and what kind of feedback or what kind of experience he has. So if you want to know more about HCP Vault, please join this user group. I'm organizer of this user group as well, so you can go there and sign up and then join this Zoom call 12th of May. So that's pretty much it. I don't have any other news, and as I said, I'm not going to talk about news in the Terraform kind of community or new releases or new things, because I find them much more interesting to be covered in the newsletter. So once more, please go to Weekly.tf and subscribe there. You can also subscribe via RSS feed, but emails is fine too. So let's move on to the main subject. Well, the main subject of this stream is going to be about AWS EKS. I will have Andrew Sapozhnikov, who is team lead of Mad Devs, the company behind of this project, which we are going to talk in a bit. But well, how to? Let's see. If I click here, does it work? No, it doesn't work. Well, it's unfortunate. Let's see. If I click here, no, it doesn't work. Oh my god, it's me again struggling with all of this. How to add myself to... Oh, here is it. Oh my god. So, I hope you didn't miss me for 8 minutes. But let's continue. Oh no. Yes, okay. Sorry, I usually have technical difficulties, which is, well, the reason why I have job in first place. So, okay, let's continue. Sorry for those technical difficulties, and I will change it. So, this project, AWS EKS-base by Mad Devs, has been created by company, and Andrew Sapozhnikov is working as team lead there. So let me bring Andrew now, and hopefully things will work. If I click something like this, no. If I click like this, yes. If I click like this, yes. Oh my god.
I can see me.
It's working. Great. So, well,
Hi everyone.
you can see, yeah, and I think people can hear you too, which is great. So yeah, I need to make my background like this so that people don't see why Terraform Workspaces is not best thing. Okay, so here we are. So yeah, welcome Andrew, and let's get, oh my god, let's get, and
It's a tradition.
It's tradition, and it's every time when I do this. Yeah, okay, no problem. So let's talk about this AWS EKS-based project which you guys created. So first of all, well, can you say a couple words about like what is this project about? Well, why did you start it and something like that?
So I think we should begin from what is AWS EKS itself. So it's Amazon's managed Kubernetes service, and we use it a lot, despite the fact that our managed Kubernetes journey started from Google Cloud Engine. We won't cover here all differences between cloud solutions, but we rather talk about how to create EKS cluster using our boilerplate and its underlying infrastructure, and more important, what needs to be done else in order to get usable cluster for your team. Because creating EKS, it's only beginning. You need to collect metrics, logs, expose services to the internet, deploy your applications, and many other tasks. And this doesn't work out of the box. So we made this project to not repeat ourselves and to help people
Right. So this is what.
use EKS.
Right. So this is pretty much the definition of boilerplate, right? So you have something at the very beginning, and then you put something kind of on top of it. Maybe you customize it, and then you have to actually live with it somehow, right? In most cases and
Yes.
in most situations, and I'm really sometimes upset, and I have some pretty long discussion with many people who prefer to have hello world example pretty much everywhere. Well, but your hello world application is not what you earn money for, right? So you have EKS cluster created, and then you have to update it, deploy it, fix bugs, get logs, get metrics, and so on. So that's a lot of work. So great to have
Yes.
something started, and now you will probably explain us how you kind of how you solve these problems, right? So
Okay.
can you
I think
explain?
I can. I'm sorry, Anton.
Yeah, no, I just want to ask you is can you explain like in more details how exactly you solve these problems? So if I want to have my EKS cluster created, what should I do?
Mm-hmm.
Like with this
Uh,
project?
you mean using our boilerplate? Yes.
Yeah,
Uh, you can just apply first layer from Terraform directory.
right. So this is a structure. So I probably have to
Yes. Yes.
clone this template
Mhm.
somewhere,
Yes.
click somewhere here, right? And then
Mhm.
go to Terraform folder. Wow, what is it?
Yes. This
Terragrunt.
folder contains the main Terraform code. So as you can see, you have modules directory. It contains some self-written modules. We are going to change it too, because as you can see, there are a lot of IAPOR roles and policies modules that so another directory, yes, there are two another directories, layer one and layer two. We decided to name them like so. So first layer basically is AWS resources. So we create here ECM certificate, EKS cluster itself. We create DNS zone in route 53, VPC, and other basic AWS resources. So first layer manages all AWS resources,
Right.
and
Yes.
the second one, if you go to the upper level, yes, the second one installs. We decided to treat all services that we use in this boilerplate as infrastructure resources too. So that's why we use Terraform in first place to deploy it. So all these configs provision different resources that should be deployed into Kubernetes cluster. So as you
Right.
can see,
Yeah. So
there are a lot of them. We can describe each of them, or just quickly tell about what does it mean.
right.
So
So here I understand the point.
mhm,
So if we look into each of these files, then you utilize the
mhm,
same pattern pretty much everywhere, right? You generate
mhm,
the template, and then you use
mhm.
Helm to do the release itself, right?
Yes, you're right. Yes.
What is Helm?
Uh, Helm, it's a tool to distribute, to package and distribute your application into Terraform. So it uses Go template files. So you don't need to rewrite your Kubernetes YAML resources each time. So you can use one, for example, uh, chart, so-called chart, and
This one.
deploy it with different values to the cluster.
Right. Yeah, I think in general it's pretty common sense and pretty
Mhm,
well-established pattern to use Terraform to do that.
mhm.
Like to use Terraform to not just provision infrastructure and change
Mhm.
color of light in your room, but also to do something something where Terraform is pretty good at is changing file contents as well, and release them using Helm. Do you have any
Mhm.
difficulties with that, or what was your experience?
Uh,
Sorry to interrupt you. I think we have a lot of colleagues of you,
yeah, seems like they.
so that's really good. Uh, and Denise is probably asking how many people were involved in the creation of this boilerplate. Uh, well,
So,
that's a good
should I
question.
answer right now?
Yeah, you can answer this.
So basically, the whole our team right now is 7 people
Hmm.
in our DevOps engineer team. I think be more cloud engineers right now than DevOps team. So yes, 7 people created this boilerplate and still
Hmm.
maintain and update.
Right. Okay,
So,
let's continue the discussion about
mhm.
Helm, because I think it is quite interesting part. And
Okay, let's go.
if people want to chime in and say their experience with Helm or with using Terraform to deploy resources, I cannot stop you guys. There is chat. Please write your message, and we can discuss it too.
So okay, let's go back to Helm release.
Yeah.
Uh, so uh, we struggled quite a lot with this resource in the past because I think let's say 2 years ago there was only Helm 2 which used Tiller server in order to communicate with Kubernetes cluster and to deploy releases.
Hmm.
So we got a lot of timeouts because Tiller definitely was a bottleneck. So, for example, if you have big release like ELK stack, for example, you can open templates and look through ELK YAML. ELK values YAML, yes, it's around
Yeah.
600
Yeah.
lines of
575.
code.
Yeah.
Yes, yes, it's quite a lot, and it uses. We use here so-called umbrella chart. So it includes a lot of smaller subcharts, and all of them have their history of releases. All of them have their states, and on top of that, we have Terraform state. So all this stuff led to timeouts, and it didn't matter where you apply from, using
Mm.
your high-speed internet, using your mobile internet, using your AWS instances and CI/CD workers, etc. So much our life became much easier after Helm 3 was released, and also Helm 3 support was added to the Terraform. I think it was in February 2020. So we are glad to to use Helm 3 with Terraform for a year now, and
Mm.
so yeah, life became much easier. But by default, for example, Helm release sets max history its max history of each release to 0. So it means unlimited. And after some times, I'm sorry, each release, Helm release, oh, I'm sorry, Helm 3 stores versions and history in Kubernetes secrets. So if you quite actively develop and deploy some application or service using Terraform, at some point you will get again timeout because there is a bug. Uh, there is hard-coded timeout of 60 seconds. And while Helm try to get all these secrets, to render them, to make a div, it spends a lot of time. So again, we can hit this timeout bug. So it's necessary. You can, for example, open any of, for example, external DNS or something. So we set here in Helm release, we set max history. So yes. So by default, we set it to 5, but you can change it. So you definitely should limit your history, because at some point you won't be able to operate with your Kubernetes using Terraform and Helm release.
Yeah, exactly. And have you considered other options than Helm release? Because from my experience, this is not the most the most popular option out there. That's why there are infinite amount of tools which people use in addition to Terraform. So Terraform is used to do pretty much everything except the deployment itself.
Yeah, you are right. We try to use, I think I'm not sure, should I tell it? We discussed it previously. We used we looked to Helmsman also, yes, but stopped at Helm files. So so this two-layer structure was born at at those times when we used Terraform in order to provision infrastructure resources, and another part was just set of releases combined in Helm file to deploy our infrastructure services into Kubernetes. It was okay for Google Cloud, as I remember, because there are not so many resource names and IDs that you should transfer between your, for example, your Terraform and Helm. But in AWS, it was very difficult to use. As I remember, in Azure also was not very usable with Helm. It's just my opinion. So it's much easier to use a single tool because you can use interpolation of Terraform. You can use its state. You can keep everything in its state. So you shouldn't. I mean, you don't need to provide some manual work, for example, to copy and paste some secrets, parameters, and resource names, etc. So
Yeah.
we, after Helm release, third version was added. So we decided to go back to this to this approach.
Yeah, I'm just, I cannot resist to not share this image. Let me share it now. Hopefully it works. You can see it, guys. This is when people use Terraform for pretty much everything. You can see, right? You can see, you can see how you can use your head. And this is one of my favorite image which I put into some of my presentations when I talk about how to use Terraform for pretty much anything. So yeah, I completely agree that you can use Terraform, but also there are other tools designed specifically for that.
Yes.
So, like in some projects, we use Helmsman, which is pretty decent for that use case. But I agree that there are different options in general. So
Yes.
that's
Another approach is, I'm sorry, Anton. Another approach is to use GitOps, for example. So you the only truth of the only source of truth is Git. So the system should be deployed into Kubernetes somehow, and then it starts to deploy your services and application. But we decided to stick with this approach, like everything that is necessary for infrastructure. We decided to treat this as infrastructure resources. So the best tool to use or to provision all this stuff is Terraform, of course.
Yeah.
So,
Yeah, that's pretty much true. Well, I forgot what I just wanted to say. It was
I'm
something
sorry. I'm
smart,
sorry.
something smart, but I just forgot it. Okay, let's move on to other thing. Well, so when I look into this structure and I see that there are a bunch of different files, and I can see that there are pretty clear separation between infrastructure resources and then Kubernetes resources. Can we look into how and what is actually Terragrunt? Can you just explain why did you mix these technologies like Terraform and Terragrunt together, and see how, like, why on earth do you have to mix these technologies together? Usually you use one and say completely opposite or something very bad about another technology. Like, for example, oh, I use Terraform and I hate Terragrunt because it's another tool, it makes complexity, it does this and this, and everything is so bad. On another side, people say, oh, I use Terragrunt and I don't know what is Terraform and I'm so happy. Why do you mix these two technologies together?
To be honest, it will be interesting to meet someone who uses only Terragrunt, for example, and its approach to transfer some inputs into modules, some all this invocation of modules or sourcing, because we tried to do this and it was quite I think it was quite ugly. So yeah, we used Terraform quite a long time, only Terraform. So we didn't use any other wrappers or such helpful tools like Terragrunt. And before we decided to publish it to open source, this boilerplate, as you know, state configuration is hard-coded, should be hard-coded. So
Well,
we
that's
decided to.
yeah. Sorry, that's exactly the point which I'm trying to make. Is that when I look
Mhm,
into the source code here, I
mhm,
see backend configuration, and I'm quite
mhm,
happy about it.
mhm.
So then I look into layers in Kubernetes, and I look
Mhm.
into, I think somewhere here, main, and I see that you
Mhm.
are using remote state here. This makes me cry.
Yes.
I
Yes.
mean, why do you mix these two solutions together? And then if I look into Terragrunt HCL inside of this one,
Mhm.
then I can see that, well, you actually have access to the dependency so that you figure out, but nevertheless, you still use data source. So why do you mix this so tightly together? It's like
Uh,
this is at the point of Terragrunt in addition to consistent remote state management, and you just eliminate this feature here. What was a reason for that?
Before we implemented Terragrant here, so as I mentioned, we used only Terraform, and that's why this I would call it legacy stuff with data source of remote state. That's why we left
Okay,
it here. So right now, Terragrant,
let's
the
figure
main
out
function of
let's
Terragrant,
let's figure out who to blame. Okay, it's you.
yes, it's me.
Then we know who to blame.
Yes, right now the only function of Terragrunt configuration is to generate backend configuration. So I think we will move forward toward this direction
Okay,
in the
then
future.
let me ask you another provocative question. So you say that you are happily using Terragrunt for remote states. Why on earth would you combine this with workspaces?
It's a great question.
I see
Uh,
Fox
I,
and few people also put different what is it emojis.
emojis,
Yeah,
fire emojis.
yeah, fire
Uh,
emojis.
as you can see in upper comment, Devin say that fluxes are everything. Yes, you're right. I agree with you. So why workspaces? uh, Great question. If we step back a little bit, let me try to explain where all this workspace thing
Yeah.
came from. So in the past, our approach was to use workspaces. So I think it happened when we developed several big projects where one of strict requirements was that each env should be almost the same with maybe minor differences in resource classes and some differences in resources. If they did rise, we resolved by our mighty count. Also,
Sorry to interrupt you,
Mhm,
but when I hear something like this, when people say we want identical environments, it reminds me
mhm,
when back in the days people were telling that you can write in Java because it works on all platforms.
mhm,
You can use workspaces because everything will be identical, except that you need to do difference in development and in production and different providers, different versions. Everything is different.
mhm,
But the ideology and the final goal is, I mean, at least in planning, usually looks very optimistic. Is that yes, we have to
mhm,
have staging and production close to each other, no automation. But then at the end of the day, we have we have questions like, yes, we need to use GitOps. Funny, sorry that I derailed this a little bit, but earlier this week I had just a random appearance into Clubhouse. For those who don't know,
mhm,
this is it still exists. I don't know why, but Clubhouse had a group where people were talking about what is it, KubeCon, which happened this year, and there were like 20 people talking, and one of speaker asked like, "Hey guys, we all heard about GitOps. Can you please tell how do you actually implement it? Because we all know that it sounds cool, but what is it really?" And none of these 20 people were able to say anything what is like, yes, we use this and we do this and that and that. So people were like speculating about it and bragging about it. It's funny to realize that this is one of these noisy technologies, noisy approach, which is cool and people want to use it, but at the end of the day, they still write legacy code and deal with workspaces.
I
So
think
go back to workspace.
this is the real pictures of conferences.
Yeah.
So another, I think, as I remember, also these customers were against of using community models. So we had to write a lot of stuff from scratch, and it was a very big waste of time. And we didn't want to copy and paste this, so we decided to try workspaces. In the end, we had something like secrets we stored in the secret manager. Inputs were placed for inputs for each workspace were placed in different TFR files, and there were the only one instance of the code. At the beginning, it worked quite well, I would say, because the amount of code was very small. But after some period of time, everything had changed. And for example, accidental implies in wrong workspaces, destroys, or for example, postponed and delivered updates to required environments. These were not very not very bad issues with workspaces. So in order to prevent this, we simply made separate branch for production, and both for staging and production infrastructure were deployed were deployed by CI. So each feature we still continue to use workspaces to develop features. So we created new workspace, provided some work there, then you create pull request, and after it merged, workspace was destroyed.
Yeah, so
So
this is I'm not sure if I'm so happy to talk about workspaces over and over during these live streams, but anyway, I don't mind, honestly. So, by the way, there are a few people say that hello from Dubai, hello from London, and are you based in Bishkek, right?
yes, in Bishkek, Kyrgyzstan.
Yeah, so we have pretty diverse group of people today, which is pretty cool. So sorry, I have a question. Is there any problem using workspaces? And there are a few approaches, I would say. I will try to be extremely polite and not polite, sorry, I'm always polite, but I will not try to convince you on anything. Okay, so I just want to say that there are multiple approaches, and you can go with Terraform Workspaces, Terraform Enterprise Workspaces, Terragrunt, and a bunch of other solutions in between. But I don't think I have ever seen combinations of Terraform Workspaces with Terragrunt. So that's the main thing which we are trying to kind of to discuss here. Yeah. And by the way, Nikolai just mentioned that I have a couple of talks mentioning workspaces. Workspace Police already comment. Oh my god. Oh yeah. Yeah, Workspace Police. That's definitely a good term. We have to call the cops right now. But as I said, if you used it before, and you figure out that okay, you can do the same with Terragrunt, I can think that right now you are not using Terragrunt the most effective way because of this thing. And from technical point of view, you probably would be better using just Terragrunt completely and eliminate this need, because where challenges may be is that if your Kubernetes stack, like in this, your Kubernetes layer 2 would be dependent on AWS, but in reverse. So your AWS would be dependent on Kubernetes. Then it would be a very painful job for Terragrunt to handle. For example, inside of your AWS, you create, Route 53 records based on information which you retrieve from Kubernetes stack. So this would be a chicken and egg problem, I have it pretty often when I work with serverless right now, because everything is dependent on everything, and there are 5 levels of dependencies, and then you figure out that all of them are circular. So you need to break them somewhere in between. And honestly, I don't know a good solution for that in Terragrunt, but here you have pretty linear dependency. AWS is created first, and then Kubernetes is created second. And if you need to change anything in AWS, you can simply go to that folder and change it and apply it, and that's going to work. Okay, let's. Yeah.
Can you tell me how Terragrunt will handle this transfer of the output from layer 1 to layer 2?
It will, like if you have this file here, if you remove this skip outputs, and then if you would have to, I mean, you will have to write input because your module here will create or will have some inputs from this layer. So then you can set these inputs inside of like here you have to write inputs block.
Inputs are values for my variables.
Yeah. So they will be retrieved from this folder. So what Terragrunt will do is that it will simply go to that folder and it will execute Terragrunt output, get this into big JSON file, pretty much what you have right now in your data source, Terraform remote state. And then it will populate these variables and they will be available inside of this as the values for these files. So
okay, if I want, for example,
it will be a little bit more
nice,
more
and tidy.
Maybe tidy, but at the same time, it will be not so tidy, because you will have to either handle information about all of this. Let's say information from all of this remote state as one huge map, which is pretty convenient, or you will have to split it into a bunch of variables the way you want. Here you're using one big map, and which is totally fine. So the approach here would be that you have to add source somewhere here, somewhere in this file, as well as inputs. And inputs will be dependency.layer1.outputs.something.
And how can I adopt this boilerplate in order to use, for example, two environments?
Well, the first thing is that you move away pretty much all of these files into a module, and then you include this module inside of your Terragrunt version. So what you will have at the end will be a folder called layer2-kubernetes-dev, where will be a point into your version of layer 2 Kubernetes of specific version, and it will have its own set of inputs. And then there will be another folder called layer2-kubernetes-prod, which will be looking pretty identical, but probably will be pointing to another version of the module. I can show this in somewhere here. So this is an example. So you will be pointing, like have this block, and this Git repository is going to be, it can be your local path, for example, or it can be remote Git repository, it doesn't matter. And it will be pointing to a specific version, or it can be master if you want.
Can I set as a source module from Terraform registry?
No. No. We have this issue open for, I don't know, 3-4 years now, and nobody seems to be willing to fix it. But the issue is open, and it is there. The reason why it's not there is because Terragrunt is what Terragrunt is doing. Well, there are some technical limitations I don't remember right now, but it's not supporting registry. So what you have to do is something like this. So that's what I write. So I write, I cannot use Terraform registry URLs, but I use the same URL as from the registry.
Okay.
And then you specify inputs for whatever you need. So if this is going to be for your dev environment, then it will be getting inputs for your dev environment. And you can probably do something like this: dependency layer to AWS.outputs, and then one huge map will be here. The cool part in this approach is that you will not have to update. Well, let me see. Yeah, you will not have to update pretty much anything. So your Terraform state file will not be changed, because you will not wrap it into the module. And the way how Terragrunt works is that it will download all the module and it will go into the module. And for Terragrunt, it will be exactly the same as you are working inside of local directory. So all of these files will be pretty much local to the module. So you don't have to use Terraform state mv command to go through all resources and move them to the module, which is pretty convenient in this way. And by the way, there were recent addition, which I'm not quite sure that I understand because I didn't try them yet, but they are related to this. So if you look here, this is what was released a couple days ago. You can now run Terraform plan and Terraform apply and specify -replace, which is a synonym of doing taint command and then apply. So previously we used taint and then we run apply and then we, so now we can just say replace. I'm not quite sure that this was the most kind of required feature or most useful feature. To my mind, we didn't have issues even with taint. It's so seldom when we had to run that command anyway. But yeah, correct me if I'm wrong, but from what I understand here, this is just a replacement of taint. Maxim is writing question. Great, we can take this question. How does Helm release resource handle diff between installation? Does it show only changed things? That's a good question. That's a question to you.
Yeah, so we again returning to Helm release thing.
Yeah.
So by default, for example, Anton, you can open any of, let's open external DNS, EKS external DNS, yes. So as you can see, to generate template, we use old data template file resource. And Terraform, if you change something in your YAML template, Terraform will show you previous version and render a new version without any hints what had been changed. So we talked about earlier that if you have quite big template, so you won't be able to debug it and to check whether it's your changes that you want to apply. So
I just want to mention one more thing here from the release which happened recently. There was update HCL to allow better planning of dynamic blocks, which is somewhat related to this notion where you have huge things and then in fact you just change one line then. It happened to me recently in CloudFront distribution template where only one thing was changed, but Terraform said that everything has to be kind of recreated. But only one small element inside of dynamic block was changed. So this is this is pretty good improvement in Terraform to my mind. And similar things, I guess, is inside of template file resource, where you have huge file versus another huge file. As I like to say, you should be happy that at least the content of the file is not base 64 encoded. Then at least you can at least compare it.
So yes, but now since recent update, of the Helm provider, we can skip all this output of the data template. So first we are migrating to template file function because it's more convenient to use. And another thing that Helm provider added experiments block. So the first thing that they did.
Is it somewhere here?
Yes, it's not
Somewhere here.
here yet. Yes, so you should add after Kubernetes block, you should add experiments block where you set manifest to true, and uh, this will tell Helm to output only the part that you have changed. So it's became much more convenient than before. So
How
it's
could
another
we?
reason.
Yeah, that's pretty good that this is kind of changing in this direction.
Mhm.
I'm just trying to think about how would you solve this problem. Let's say if there is no such thing. Can you explain what can be the workaround when you have one huge YAML versus another huge YAML and you want to compare them? Do you have any ideas how this can be done?
Uh, you could use regular Helm command with diff plugin. So uh, you can generate this values template to the, for example, to the file, and then run diff using Helm command, and
I
you
see.
will see the exact changes that you are trying to apply.
Yeah, that's pretty nice workaround. And well, if it is possible to do like you say, then I don't see a huge value of having this experiment added here because that thing is it's probably gonna
You
to
can
work fine.
show us again this your favorite GIF.
Yeah,
That's why.
yeah. Well, but this is what we have to use, right? I mean, if there is
Mhm.
no workaround, like no easy solution inside of provider which we are using, or there is a bug somewhere, then yes, this is what we have to do. And there are many different places when we have to we have to kind of
Mhm.
use Terraform for pretty much all different things.
Yes, because
Okay,
you told me that you are using Terraform to deploy serverless functions.
yeah.
So
Yeah, that's what I do, and I have a
Mhm.
lot of similar things there. Like Terraform was not the best tool, kind of. I mean, it is the best tool out there for many cases, but
Mhm.
when it comes to specific like niche things, then I'm really willing to drop everything and just use SAM. But then after 2 minutes with AWS SAM, I realized that, oh my God, there are the same problems, but they are just called differently. And then I go back to Terraform. So then somebody say like, oh, you should use Pulumi. And then I say, okay, let's go to Pulumi. And then I go back.
the same story.
Yeah, but actually this week I met first customer of Pulumi for the first time ever. I mean, outside of Pulumi themselves. And they say like, yes, we are using Pulumi and we are happy we have this and this. So it was pretty good to talk to them. Okay.
Interesting. Did you try CDK?
Well, yes, I tried, and well, I tried and I tried it a couple times, and yeah, it's not exactly what I have difficulties with. That's my
Mhm.
point. Of course, I can make it to work, but well, why should I do this if I have been developing things for a pretty long time and I know how they work? Specifically, Terraform AWS modules, which you use here, right?
Mhm.
So that's one thing which I want to also ask you. Am I right that in order to set up AWS infrastructure, you use pretty much for everything Terraform AWS modules,
Yes,
right?
you're right.
Even this EKS, yes. Hello, Tierna, if you are watching this. Tierna is developer of this one, and he's very
Thank
active.
you.
Yeah, so he is doing great job with all of this.
Yes, it's a great model, to be honest.
Yeah, and he's the one who is following semantic versioning as it should be. So you can see how productive he is. He is actually releasing 15 dot something, not like Terraform where they work for so long time and just 0.15. Look at Tierna. Yeah.
So yeah,
Okay.
we can't. I think we can't keep up with the community regarding these Terraform models. So of course, at the beginning, I think for practice, you should try to write your code, your models, because how would you understand uh, what you are trying to apply and what you are trying to use? Because
Well, you
first
can
thing,
read
for example, that
documentation.
I'm doing is to check what does this module do. Uh, I don't know. Maybe it's some hidden bash script that
Yeah.
sends something to by curl.
Yeah, that's a good point, and actually that's quite a relevant concern in some situations. People are asking like whether we have to fork this one and maintain their own fork, or what is actually the guarantee that there will be no curl embedded into this module
Mhm.
uh, in patch version which you wanted to get, but then hey, there is curl.
Mhm.
Yes, and I don't think Terraform registry has added enough what they can do to prevent this from happening. But
Mhm.
this gives a lot of opportunities for other companies who are specializing in infrastructure as code security to come up
Mhm.
with different tools which will be embedded into your CI/CD pipeline, which will somehow restrict, let's say, you consume any kind of code, but
Mhm.
we only allow this code to access to this provider, for example,
Mhm.
and we only allow you to use these IAM policies, for example.
Mhm.
So right now there is no easy way and no easy kind of contract between module developers and module consumer what this module is
Mhm.
going to do. And this has not changed, but I still hope it will be implemented in the future.
Yes, but also all these community models are very, very great source to learn
Inspiration, it's
because
called. It's called
uh,
inspiration.
inspiration. Okay, because there are a lot of hacks that I didn't even know that they exist. So.
Yeah, yeah, that's a cool part. Is that sometimes we add hacks because we want to get problems solved. And then we see, oh, okay, there are actually people who are copy pasting this stuff and they using it, or sometimes they customize this hack to be more flexible. So it's always a moving target. And that's one of the points in modules is that if you will start do this like from scratch yourself, you will do this no problem. I'm not saying that pretty much like impossible to do, but there
Mhm.
are much more people and much more efforts already put into these modules than any
Mhm.
company can allocate themselves. There was another
Yes, sure.
question from Maxim. Why did you divide code into two layers? Was it only because of the nature of resources, AWS, EKS, or there were any other reasons? That's a really good question. I also wanted to know why. Why two? Why not 25? Why not one?
Uh, I think if we continue to use Terragrunt and to moving toward its approaches, then it will be 21 modules,
Not
independent
necessarily.
modules.
Not necessarily. The point of Terragrunt is that you can tell that, okay, everything what is inside of this folder, layer 1 AWS, is now a
Is one
module,
module.
is one module, yes. It is called infrastructure module. Well, at least I call them infrastructure module, but maybe that's not the best name, but here they are, code structure, key concept. So
Yeah.
here they are infrastructure modules is a collection of resource modules which can be logically not connected, but in current situations they are serving the same purpose. And the same purpose here is to get AWS infrastructure created. That's it. So that's a infrastructure module for this one, and then maybe one module for Kubernetes, one or two or three. It depends.
Parts.
Yeah.
Yes. As I understand, we also can speed up Terraform apply or Terragrunt apply using Terragrunt, because if some modules are independent, we can run them in parallel. So
Well, that's a little bit tricky with Terragrunt. Is that Terragrunt takes a lot of time to actually to implement this lookup. So when you mention something like dependency blah 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 dot outputs, it means that Terragrunt will have to go to this folder which you specified, and it will execute Terragrunt outputs, and this usually takes a lot of time. So it's not really a big win. There are a few optimization which you can do, but I still have not implemented them in any project because they are a little bit fragile, especially if you have many dependencies. Let's say Kubernetes depends on I don't know, on AWS, on I don't know, on autoscaling group. Autoscaling group depends on VPC. Then Terragrunt will try to resolve all of them, and that's not always what you want. So there are a huge amount of issues and documentation inside of Terragrunt documentation about how to optimize this one. But as I said, I couldn't make this to work so easily yet. So my execution usually takes a large amount of time if the module is big. That's why I split them. Usually I split them by resource module, where I have one resource module for let's say VPC, one for autoscaling group, one for that. Then it's not so bad.
Okay. So 2 layers. First layer we use to provision all AWS resources. Yes, we could use, for example, in apply all this stuff in one directory, for example. But the plan will last quite long time, I think. And
Well, I can tell you a little bit more. You will not be able to put this into one directory because there will be some things which, at least the way how you probably created this code, I may be wrong, but if you, let's say, somewhere put count inside of resource and you reference to something what Terraform does not know yet. So, for example, you deploy You deploy Helm release into
Kubernetes namespace.
yeah. So okay, this one thing is not known right now, and you want to include this conditionally. For example, you want to create Helm release certificate if this namespace dot something equal true, for example. And you put this one into count inside of this resource, right? Terraform will not be able to do this even now if you're referencing to something what is not computed yet. And this is one of the famous issue which is not fixed yet, where Terraform cannot use something what has not been computed. And this is exactly the point where Terragrunt still wins. Terragrunt clearly limit that, okay, first you need to create this module, and only after this module is created, then go on and deploy something there. So by that time, when you call this kind of code, Terraform will already know the value which will be referenced inside of count, and it will be treated as computed, and everything will be fine. So it's not exactly the win-win situation if you use Terragrunt or Terraform.
Okay, and can you tell me, for example, if I decide to stick with Terragrunt and drop this remote state data and workspaces and etc. etc. So how can I run, for example, Terragrunt plan on both of these resources? How to do this?
You
I
probably
mean,
will have to go to this folder where this folder
dependent
will
node.
be dependent on AWS, and you will have to run inside of this folder. You will have to run apply all from the folder, and it will ask you. It will simply tell like, hey, I see that you are referencing something outside of this folder. Do you also want to run Terragrunt in those folder too? And you say yes. This means that Terragrunt will execute a code inside of your AWS folder first, wait for that code to be executed, get outputs from that one, and populate these outputs into this layer 2 Kubernetes. So your main folder where you will have to be executing code will be Kubernetes, and you will have to run apply all. In most cases, you don't need to run apply all. And again, apply all is pretty dangerous command to my mind, because you don't have enough control, and you say like, yes, I want to create everything, which is valid point only if you don't have anything to lose. But if you have something running in already with some load, you will have to do this by going to Kubernetes folder and run just apply and limit your load only to this one.
And how to run plan before apply?
There is no way.
So Terragrunt
No, I mean,
respects only brave
yeah,
bravery.
yeah. We need brave people to work with Terragrunt. No, that's
Okay.
that's actually well. There were some things I just don't remember right now. There are some updates periodically happening in Terragrunt, but I'm not following it so closely right now. In kind of general terms, is that yes, you should be able to run plan. The problem here is that this plan will often happen in parallel. If you have multiple folders, your output will be mixed like crazy, because Terragrunt will execute Terraform plan in all of these folders if they are not dependent. You can limit this. You can specify that you only want to run with parallelism 1, then output will be pretty decent. But still, it doesn't give you kind of enough information of which you can trust. I think the problem here is that Terraform itself is a little bit too verbose. Yes, there are some efforts going on related to improving JSON plan output, but this is only when sensitive value is used. But in general, JSON plan can be used, and you will be able to, if you have JSON plan, then you can at least somehow filter values from it and see not green text by Terraform init command, or that provider was downloaded or something like that, which is not relevant for you right now, but only what is meaningful for you. Right now, this is not implemented in Terraform in the way that you can easily execute Terragrunt plan or plan all, and then see code similar how Pulumi does it very nicely, where all output is grouped by resources or by modules, by stacks. I don't remember how they call it, but you can actually figure out quite nicely what kind of changes are gonna to happen in all of your stuff. It's not like infinite amount of text in different colors. And sometimes actually in between there will be error, and then it still continue because it means that error has happened in one of the dependencies somewhere. But it doesn't mean that everything stops. So it still continue doing this, and then at the end it will say error, and good luck figure out where exactly it is. So yeah, it's more like technical implementation of Terraform and Terragrunt to my mind. But from ideology point of view, I believe it's meaningful to know what exactly is going to happen. So you need to run some sort of plan command. You can run plan, you can run apply, but not apply. It's the same things. Yeah, one more question. Maxim is asking great questions. Thanks for that. Do you use this boilerplate only for infrastructure, or you deploy application the same way too, like external DNS, for example? Well, I think that's what we discussed, right? We have external DNS.
I think he's talking about application that developers need to deploy.
Oh, he
So
said,
do we deploy?
yeah. Then he clarified, I don't mean service applications. So yeah, exactly.
So yes, this boilerplate is used to prepare Kubernetes cluster in AWS, and the whole is services that help developers to monitor and to watch their logs and etc. etc. So to help to operate without help of operation team.
So what kind of work does application developer have to do in order to deploy an application like this?
So usually we are using GitLab or GitHub as a Git repository, and also their CI systems. So our task is to deploy some runners for GitHub to the cluster. So after that, the whole process comes to the code of these applications. So usually we help them to write some Helm charts for the applications, and that's all.
Okay, but in
We
terms
don't
of
use this.
in terms of code, do they have to write, let's say, copy one of this file and put the what is it, Helm template somewhere, or how is it?
Values template.
So they will.
No. This boilerplate only for infrastructure is only for infrastructure. So they don't use it to deploy applications.
Okay, so you deploy application differently.
Yes.
Okay, how different?
Uh,
Just briefly,
usually,
I'm curious why not
yes.
consume the same approach? Yeah, that's a question which Maxim just repeat. Do you use Terraform to deploy applications? That's exactly what I want to know as well, because why not?
Because why do we need to grant the access to the Terraform state, to the infrastructure for developers? We try to prepare everything that the only thing that they need is to write the code to build Docker image, and then CI will do the other stuff, the rest. I mean.
Yeah,
So,
I understand that developers do their stuff. That's obvious, but then where does the configuration for the application live? I mean, is it in Terraform code, which is then applied by something, and who is applying it is not the biggest question here. I mean, yes, CI can run Terraform apply quite easily. That's not an issue.
Mm-hmm.
But as a developer, I have to write code and I have to provide some values.yaml file, which is going to be consumed later on by some CLI. And the question is, why not to put this into Terraform? Like, why your deployment script is calling Helm CLI instead of running Terraform apply and do everything at once? It can be different state, of course, but just the same tools.
Good question. To be honest, we from one side we are trying to use one tool for everything, and from another side we are we
Because
try to
you are already using Helm here, and I guess you use Helm CLI to do deployment too, right? So that's exactly the same things. So maybe Helm release is not so powerful as Helm CLI, but to do these kind of things, if you limit max history, for example, then it shouldn't be an issue. But again, it's probably a little bit too broad, and it depends. I mean, if we are talking about GitOps, this is the way how it should be implemented, according to Clubhouse discussion which I attended. But it was so funny. Okay, I think we have covered pretty much everything what you guys created here. Can you tell about what do you plan to do next with this, and how do you plan to improve it, or maybe add more features or bugs? Well, there are just 10 issues, so it's not enough. There should be more.
Yes. Feel free to to write something. So of course there is a lot of work to do. So we are going to polish the documentation. I think we should some known problems and their solutions. Also, we are going to replace all these self-written IAM modules and change them to community modules. Next step is to move all these Helm releases into separate modules, because we don't want all these example directories that are quite useless, to be honest, and uneven. So it's better to set your configuration using, for example, TFVars or maybe Terragrunt configuration, which application you want to apply. And yes, you was quite inspirational in your Terragrunt.
Well, but that's one thing which I want to highlight as well. I can say that Terragrunt is a good tool, but at the same time, I can say why Terragrunt is bad here. And why I would not write this in Terragrunt in first place myself. The adoption of Terragrunt is pretty big. I mean, a lot of people are using it and they're quite happy. But if you're making something what is going to be executed by users, you will have to focus on Terraform as well. Like your primary use case will be that people run Terraform. Once people understand how this can be run in Terraform, it will be extremely easy for them to create structure like this one, put your module into the source, and provide their values into input. That's it. So your project has to work extremely well, extremely stable, but 90% focus on Terraform. Terragrunt is like syntax sugar, which is cool, but you can do it pretty much the same way using Terraform, especially for boilerplates. You cannot imagine that people will use Terragrunt all the way, just because there are. It's quite funny situation. People want to use Terragrunt because Terraform does not support certain features. That's it. Not because of Terragrunt is the best tool on the planet, but simply because people don't want to do repetitive things like you do here, right? Why I should describe all of these variables and think about these hard-coded values somewhere, why this is without v and this is with v, and so on. So all of these things will have to be taken into account by users. Well, that's actually quite funny. Here you have v, here you don't have, here you have v, here you don't have. So it's mixed all the time. Yeah, so I really recommend you to focus on Terraform, and just as a kind of side thing, you can say like, by the way, this is how you can make it to work with Terragrunt, and it will be very cool from the kind of from user point of view that you thought about this use case. So you put some efforts, you described why this is possible and how it's possible. So
Thank you for your advice, to be honest.
It's quite frustrating sometimes to see that some companies are focusing completely in an existing direction. Like people say, for example, we want to do this stuff using this and this technology, and then you ask like, have you heard requests from someone who uses technology that they need this? No, but we will find them. I mean, yeah, if you have nothing to do, sure, go and go and spend your time like this. But I think that this project, and at least after I talk to you now, and when I saw the source code, this kind of solution is something what I think a lot of people will get value in many cases. I mean, to get things created, to pretty much all of these points which you described here, I completely agree to all of them. It's free. Well, it's not free because you still need to learn a lot of things in terms of time, but yes, it definitely saves time. So it's really important to understand boilerplates, why they're there. And the last thing which I want to explain, not explain, but to mention is that I personally hate word boilerplate myself, because boilerplates to me means that this is something what I look into, and then okay, this is what you do here, and then delete it completely. There is no single line left after boilerplate because it doesn't match my need, or structure is wrong, or approach is different, or something is not carefully thought through. So here I don't see this as a problem. So here I find it very good structured, good code style, and pretty decent quality as well. So for
Except workspaces.
well, there are a few other things as well, but we can talk about them later anyway.
Okay.
That's not for a live stream, but yeah. Okay. So yeah, do you want to say something as a closing word? I can bring you up somewhere here. No, not like this. Well, maybe here. No, that's a good idea. Let me see if I click here. No, here. And yeah.
I can see me.
Yeah, now we have 3 people.
Yes, and some shadow.
Yeah, okay.
Shadow ops.
Here we are. Yeah, great. Here we are. Okay.
Your
So, yeah.
favorite background.
Yeah, okay, no problem. I can turn it off because it's enough about workspaces. So
Yes.
yeah, do you have any other closing thoughts which you want to share with us? Anything?
For us, I think one of the biggest direction, and one of the maybe mysterious direction is how to properly test Terraform code. So because there are a lot of dependencies, as you told, and there are a lot of connections, and there are a lot of things that should be created before you can continue, for example. So you can't, I think, write some sort of unit tests. So most of them are basically end-to-end, and so this is the topic that we are going to work this year with our team.
Yeah, that's a
And
big topic for sure.
mhm. So
In
yes.
EKS module, there are a few things which are related to this, like when you mentioned that you create EKS cluster, but you have to wait for it to be really ready, and not just by hearing from AWS that it is ready. You actually have to make sure that it's ready before you can use it. This is actually one of the things which Tierna is looking at right now. And yeah, he will describe it in some of pull requests in the near future. But this is one of issue which we have with EKS module and EKS in general.
Yes, and I think in Terraform in general, so quite hard to automate testing of the code. So most of the time we are manual QA for our own code. So, and this topic is quite interesting for us as a DevOps team also. So another thing, yes, of course, we won't discuss this secret situation.
No, secrets is for
But
something else, for
yes,
someone
yes.
later. Yeah.
But anyway, basic security practices. So we are going to implement this in our boilerplate too. So it just right now it's just very basic configuration. So we are going to work on this, and that's all for now.
Yeah, and I'm quite sure that you can put a lot of other things which people maybe don't even know about the importance, but you can just put them there and say like, hey guys, this is how we do it. And you will get another 200 stars as soon as you mention it on Reddit, or I don't know. I don't remember where I discovered this project myself.
It's interesting.
Yeah, I mean, you have to put some. You cannot just let's say go to a well-established path and then just say like, oh yeah, this is just another boilerplate. Well, I know about a couple more projects like this, but they're not so popular and not so well thought through. So that's why people are looking at them and say like, oh yeah, this is just crap. I don't need to pay attention to it. So you can definitely add some extra things related to security, other cool sensitive things. For example, you can describe how to do deployment, how to use Terragrunt, why to use that versus something else. Or I'm personally more leaning towards learning more about how to use OPA to make sure that the stuff which I have just deployed is not actually violating some established rules. And on this note, we will have, I think in 2 weeks, I will invite guys from Scalar to talk about the OPA approach and how Open Policy Agent can be used to make sure that whatever you have created here is actually decent and not gonna to open everything. Something what you mentioned earlier is what is the guarantee that there is no curl to the external world somewhere in the modules? You want to make sure that there is no such thing. And yeah, it's kind of strange that there is not enough movement in this direction. And we discussed this recently with Scott Winkler last week, where we talked about Sentinel versus OPA, what is missing there. So we'll see.
And
Okay.
what can I say to young or to junior Terraform developers? So you opened your best practices site. So I suggest to start from this if you want to write your Terraform code. And of course, use already written and polished community models because yes, there are, I think, years of work put into each model. So try to use already well-established code first before you start to write your own.
Yeah, that's definitely a valid point. I'm glad that you repeat this because that's what I'm telling to my customers pretty much daily when they show to me like, hey, we have created 200 our modules for, let's say, for 25 flavors of auto scaling group. And I look at this and say like, yeah, but this is exactly the same things. Like all of them are the same except that you parameterize two different values somewhere. So yeah, when people get paid by lines of code, we will have this situation happening. So yeah, okay, good. Then on this note, I think we can wrap up. And thanks a lot, Andrei, for finding time for sharing your experience with us. And yeah, thanks everyone who watched this. Thanks to all of your colleagues who joined us as well. That was really good. And thanks for asking questions. And hopefully you find it useful too.
Okay. Thank you, too.
Last thing which I want to share on my screen is before we all kind of hang up, please go to Weekly.tf, and in an hour or so there will be new newsletter coming out. So Weekly.tf is where I will publish news about different kind of things not covered during this live stream. Okie dokie.
And who owns this TF domain?
Territory of France, somewhere in I think in Indian Ocean somewhere. Yeah, it's not very popular domain. I mean, it's not supported in many registrars, and well, it's not the most expensive either. But still, it's sometimes pretty hard to transition this domain between owners, and yeah, do different things. And yeah, that's it.
Okay.
Thanks everyone. Bye. Let me see.
Goodbye.